Hey guys, I hope you're doing really well this week. This is the Lenovo X1 Carbon Gen 3 laptop. This is actually my own laptop. Now, I have two of these. I use them for bringing around to sites and stuff like that because they're secondhand. It doesn't matter if they get robbed. I don't keep anything on them, but they're a great little laptop, lovely and light, nice keyboard on them, and screen is pretty good on them as well. However, this one has developed some sort of fault. It was initially powering off for no reason. It would boot to Windows and then just it would shut off, and now it is not doing anything at all. I have tried the reset button, I've taken out the battery, I've done, BIOS reset, the whole lot, absolutely everything, and I cannot get this to boot. So what I'm going to do is I'm going to take out the board, I'm going to take some pictures of the board, and we're going to start troubleshooting it on the screen. And sorry, I almost forgot, the fault. I press the button and nothing happens. I know the power adapter is good because it works with my other laptop that's exactly the same, but press the power button and nothing at all happens.
I scanned in the board and this is what it looks like. So as you can see, there's small bits of dirt around where the screw holes are, here and here, but other than that there's no signs of any damage. There's no damaged components. That's one side. You can see that there's a congregation of dirt here as well. I don't know exactly what that is. There's no sign of like a spill anywhere else in the area, but the dirt does seem to congregate around those screw holes. And this is the other side of the board. So we're going to quickly have a look at it here. What you can do is you can pause it at the different sections. I'm just trying to scroll down through the board here quickly, but you can look back on those sections and see if you spot anything yourself. What I'm going to do is I'm going to go to where the DC voltage enters the board and we're going to start taking some measurements from there. I found a schematic for this one, so we're just going to follow the 20 volts onto the board here and see how far in it's getting. So this is our jack, our DC input jack here. There's a lot of pins on this one which I can't see fully here. It only looks like there's about 4 here, but what I'm going to do is I'm just going to find the power pins. They're marked as 28 and 26 here, but if you see where that comes in, it goes along this path and onto a fuse called F2. So I'm going to start measuring there. If we look at the board here, we can see our fuse F2 is here. So that's where I'm going to start measuring. I've checked my power adapter, it's measuring 20.5 volts and I've plugged it into the board. So now I introduce my multimeter in volts DC. I place my black probe to ground and I place my red probe to the fuse, and when I measure at the fuse we're measuring 20.50 volts. So our power is getting through our DC connector and through our fuse as well. Now after our fuse, it's not immediately obvious where it goes here. I can see that there's 2 MOSFETs here, so could these be the 2 input MOSFETs? I suspect they probably are, but just to confirm it, we can go along on our schematic and we see that the next component in line is Q9, and sure enough that is our MOSFET right here. So let's find out what this is. I've found a datasheet for that SI7121DN, which is Q9, and this is a P-channel 30 volt MOSFET. So as we know with P-channel MOSFETs, they're turned on when the gate pin is low. If we look at the pin configuration list, 1, 2 and 3 are source pins, 4 is a gate pin, and 5, 6, 7 and 8 are our drain pins. So I'm going to mark them in on this MOSFET right here. So the first thing I want to check here is what is the voltage on our source pins, which is essentially the input to this MOSFET here. So placing my black probe to ground and my red probe to the source pin, I find that there is 20.50 volts on the source pin. Next we want to measure the gate pin. So with my black probe still on ground, I place my red probe carefully to the gate pin of Q9 and I find that it measures 6.73 volts. So this is low and our MOSFET should be turned on. Next we measure at the drain pin of Q9. So I'll place my red probe to the drain and we find that it measures 20.50 volts. So our input voltage of 20.50 volts is making it through our first MOSFET. Back to our schematic, we can see here that we have 20.50 volts at this point after Q9. So where does it go next? Well, where it goes next is onto a second MOSFET, which is Q36. Now Q36 corresponds to this MOSFET right here, this one right here. So I'm going to pull the data sheet and just see exactly what this is. Q36 is an SIS406DN N-channel 30 volt MOSFET. So what we should be seeing here, if this is switching on, the gate pin should be high because it's an N-channel MOSFET. Usually the gate pins on these types of MOSFETs are about 25 volts or so, or 24, 25 volts to switch it on. And if this MOSFET is then switched on, our 20.50 volts should be coming through from our source to our drain here. So once again, measuring in volts DC, I placed my red probe to the gate pin of Q36 and I find that that measures 18.65 volts. Now with the other laptops we've seen on this channel, anytime that we've seen an N-channel MOSFET on this input section here, we usually measure 25 volts or 24 volts on the gate pin of that N-channel MOSFET in order for it to be switched on. So 18.65 seems a little low, but I'm going to keep troubleshooting and we may come back to this. Now if Q36 is in fact switching on, I would expect to find the same 20.50 volts that was on the source also on our drain pins. So I place my probe to the drain pin here and I measure 20.02 volts. So there's a drop of a half of a volt. So I'm not sure if that means that the MOSFET is partially switching on or what is happening here, because the gate voltage certainly seems to be too low. So what I decided to do next was to try and bypass this MOSFET here. So I got a jumper wire, just a piece of solder, and I jumpered from source pin number 1 to one of our drain pins over here, like this. And when I did that, I measured on the drain pins then, and when I measured here, I found that there was now 20.50 volts, and I decided to try and power it on again. However, when I pressed the power button, nothing happened. Next, I just wanted to confirm that the power button was actually working. So I found the power button on this little daughter board here. That's the button. So that's the one that you press down to switch it on. So I checked these 4 pins here and I found that when I measured this pin that there was 3.3 volts on it. When I pressed the power button, that went to 0 volts, and when I released it again, it went back to 3.3 volts. So the power button is certainly working. Now if you've watched my other videos, you know that after I test the power button, I usually try and check on the Super I/O chip to make sure that it's actually receiving the signal from the power button. However, even zoomed in, these components are really tiny. So for the moment, I'm just going to assume that this is receiving the correct signal from the power button. So where are we at this point? Well, we've established that the main power rail looks okay. We have established that our power button is working, and it's still not powering on when I press the power button. So do we have a dead Super I/O, or is there something wrong on this laptop that is preventing the Super I/O from allowing this system to boot? So I guess the question is there a problem with one of the secondary power rails? Now, I have 2 of these laptops that are the same. I mentioned this at the start of the video. So I thought it might be useful to take down the diode mode readings for the secondary power rails and see how they compare. With my multimeter in diode mode, I took readings at all of the inductors, and these are the values that I measured. So on L4 I measured 0.4 volts, on L5 I measured 0.54 volts, on L3 I measured 0.034 volts, on L7 I measured 0.043 volts, and on L28 I measured 0.27 volts. And from my working laptop I took the following measurements. So just to clarify here, the values marked on the inductors themselves are the values that I measured on my faulty laptop, and the values with the red background are the values from my known good working laptop. Okay, so can anybody spot a problem here? Well, most of the values, L4 matches pretty closely, as does L5, as does L28, as does L7. But the one that is completely out of sync is this one here on L3. So the L3 value on my faulty laptop is much lower than what it is on the working laptop. So I checked the schematic, and this is L3 right here, and as you can see, if we scroll across, this is a TPS 51220. So this is the one that generates our VREG 3 or VREG 5. These are always on 3.3 and 5 volts, and it also has the two switched high current outputs. So this is a 3.3 on SW2 and our 5 volt, which is SW1. So something seems to be wrong with this power rail here. This is measuring far too low, and we need to investigate it. That's where I gotta leave it for this week, guys, but I will be investigating what is wrong with that 5 volt power rail next week, because unlike the other laptops I've been working on recently on this channel, I actually like this laptop and I really want to get it back working again, because it's a really nice laptop even though it is old. Unfortunately I lost a lot of time this week because I had to bite the bullet and rebuild my entire PC, but thankfully I'm now getting a Nova bench score of 1711 on my new i7 PC, so hopefully that's going to quicken things up and make the whole process of creating videos a lot less painful for me, because right now I'm spending probably about 2/3 of my time making the videos and about 1/3 of the time actually learning electronics. So what's happening at the moment is I'm getting good at making videos, but I'm not really getting much better at fixing electronic stuff, and that's not ideal for me either. But hopefully with a fast PC I'm going to help change that ratio. But keep liking and subscribing if you like what I do here, and I'll be back with something else next week.